Gold blocks like this, 3 of them, will finally put Einstein's theories about gravity to the test. The gold blocks are the heart of this experiment. Researchers will use them to detect gravity waves from distant cosmic masses such as black holes or supernovas. Each cube, floating free inside its own satellite, will form part of the largest scientific instrument ever built. A triangular detector 5 million kilometers on each side, sensitive to movements smaller than the width of an atom. But the predicted gravity waves are incredibly weak, too weak to be detected on Earth. At the Max Planck Institute for Gravity Physics in Hanover, researchers are tuning the lasers that will detect the slightest movement in the gold blocks. The technology will be tested first in a miniature version of one of the satellites named the LISA Pathfinder. If this mission goes to plan, 3 full-size LISA satellites will be launched. They'll be deployed around the Sun, following the Earth in its orbit, but beyond the influence of the Earth's gravity. Once in place, the 3 LISA satellites will switch on their infrared lasers and fix their position. The lasers will register minute movements in the floating gold blocks for analysis by researchers back on Earth. Albert Einstein noted that the detection of gravity waves would prove his general theory of relativity. But he also recognized that an experiment to detect them could not be built with the equipment available at the time. Einstein's general theory of relativity, published in 1915, paved the way for the discoveries of everything from black holes in space to lasers and semiconductors here on Earth. He predicted that movements in massive objects in space would create faint gravitational waves, like ripples on the surface of a pond. But he said that the waves would be so faint that they would be nearly impossible to detect. Now that's about to change.